given, the square root of 3/4. This is when we rewrite as the quotient of a radical becomes the square root of 3 and the square root of 4, which is simply the square root of 3 because it's not a perfect square, and the square root of 4 is 2. Now, this is our answer since there is no more radical sign in the denominator. When we say rationalizing the denominator, we should have no radical in the denominator. We have the square root of 3/6. Applying the quotient of a radical, we have the square root of 3 and the square root of 6. We need to think of a number that when we multiply to 6 will be a perfect square. So that would be a square root of 6. Make the numerator and the denominator the same since this will be equal to 1 and nothing will be changed in our given. Now let us proceed. 3 times 6 is 18 product, and in the denominator, square root of 6 times square root of 6 will be square root of 36. Square root of 36 is now 6, correct? And our numerator, square root of 18, can be factored as 9 times 2, right? And then we simplify. Is equal to the square root of 9 is 3. And we have the radical 2. And in the denominator, we have 6. Now we simplify the whole numbers outside. So 3/6 is also equal to, if we are going to use cancellation, 3 divided by 3 is 1, and 6 divided by 3 is 2. So, as our final answer to this given, it will be 1 times square root of 2 is still square root of 2. And then in the denominator is 2. We cannot divide the numerator and the denominator in this given or final answer since one is with a radical sign and the other doesn't have. Again, we have cube root of 2 and the cube root of 5x. To multiply this, 2 that will make the denominator a perfect cube. So, how many 5x do we need to have 5 cube? Of course, 2. So, that would be cube root of 5x squared. So that 5x and 5x squared is equal to 5x cubed. See? Okay? And there in the numerator, we have same. Cube root of 5x squared. Okay? Again, remember, this should be exactly the same. Next, we have the numerator. Cube root 2 times 5 squared. 2 times 5x squared. And then we simplify. This will now be the cube root of 5 squared, 25 times 2 is 50, and the variable x squared. In the denominator, 5x quantity cube, or in the denominator, cube root of 5x raised to 3. We can cancel this and this. So we now have 5x in the denominator. So this is now our answer. Conjugate is to get a factor which is opposite its sign but the same first and second given term. Let's have an example of conjugate. We have 3 plus the square root of 2. Its conjugate is 3 minus the square root of 2. Again, they have the same first term, the same second term, but opposite operations. Given is the square root of 5 minus the square root of 3. Its conjugate will be the square root of 5, opposite the sign is plus, and the square root of 3. This is the conjugate of square root of 5 minus the square root of 3. Square root of 7 minus 2. Its conjugate is the square root of 7 plus 2. Again, this is how we write conjugate. This time, we are going to use conjugate of a radical expression. 3 over 3 minus square root of 5. First, we rationalize by multiplying the conjugate of the denominator, which is 3 plus square root of 5, both in the numerator and the denominator. After which, we are going to multiply this. So, in the numerator, we have 3 times 3 plus the square root of 5. And in the denominator, we have 3 times 3 is 9. Square root of 5 times square root of 5 is the square root of 25. Remember, we are applying the sum and difference of two binomials. So, negative times positive is negative. Then again, we simplify this. Copy the numerator. And simplify the denominator. 9 minus the square root of 25 is 5. And finally, this will be 3. 3 plus the square root of 5 over 9 minus 5 is 4. This is now the simplified radical of our given. First, we get the conjugate of our denominator. That would be, and multiply it to our given. So that is the square root of 3 minus the square root of 2. Square root of 3 minus the square root of 2. Then we multiply. We have in the numerator 2 plus square root of 3 times square root of 3 minus the square root of 2. And in the denominator, applying sum and difference of two binomials, we have 3 times 3, the square root of 9, and 2 times 2 is the square root of 4. Sum and difference of two binomials minus. Using the FOIL method, first term, last term, inner term, and outer term. So 2 times square root of 3, that would be 2 square root of 3. And here, square root of 3 times the square root of 2 is the square root of 6. Should be minus. Okay? And then the inner, square root of 3 times square root of 3, that would be square root of 9. And the outer is 2 square root of 2, negative. And then we rewrite. This is important that you remember how to multiply binomials. You've learned this during grade 7 and grade 8. Rewrite 2 square root of 3. And then we have the inner, positive square root of 9. And then the outer, negative 2 square root of 2. And the last, we have negative square root of 6. Extend. And in the denominator, square root of 9 is 3 minus the square root of 4 is 2. So first we have this square root of 9 is 3. So this is equal to 1. So there's no more new denominator since it is already over 1. Now we have the numerator, 2 square root of 3 plus square root of 9 is 3 minus 2 square root of 2 minus the square root of 6. This is our final answer. Let's have the steps to simplify. Step 1, we are going to get the conjugate. Step 2, we multiply these two using the FOIL method. We are going to simplify. This is the next. After we simplify the denominator, we will also simplify the numerator if there are numbers that can be simplified. And then final answer is this.